Part 2 of Lesson 6 of Chapter 2 is on solving nonlinear inequalities. Today we're going to talk about solving rational inequalities. Yesterday we spent some time solving nonlinear inequalities. Specifically, we solved quadratic inequalities and also cubic inequalities. Well, today we're going to work on rational inequalities. So the problem that you're looking at here, we've got a rational function on the left, we've got a constant on the right, and we've got an inequality, not an equal sign. So what we're going to do is we're going to take a graphical approach to this problem, and we're going to graph the rational function on the left. So let's start off by discussing the vertical asymptote on this problem. We find that by setting the bottom equal to 0, and that would be at 3/4. So I'm going to put in a vertical asymptote at 3/4. The horizontal asymptote would have to be at y equals 1/4, and since the degree of the top and bottom are the same, we divide the leading coefficients, so 1x divided by 4x gives us 1/4. We'll put in that horizontal asymptote right there. And then we'd have an x-intercept at -6. How I found that was I set the numerator equal to 0, so it gives me an x-intercept here at -6. And then we'd have a y-intercept at -2, and I found that by putting zeros in for all the x's. And so now the graph should look something like this. We're close to that horizontal asymptote. We go through that x-intercept, we start to curve, go through that y-intercept, and then it goes down. And then likewise it's going to be up here, close to the asymptote, and then it starts curving. Now this is just a sketch, but what we need to do now is we need to identify when does this rational function, when is it greater than 1? So I'm going to put a horizontal line in at 1, and now our objective is to find out when is the blue above the yellow. So with that being said, we've got a graph here, and our solution is going to be all of these points right here, because that's where the blue is above the yellow. Now clearly there's an important point. The important point is the intersection of the blue and the yellow, and I'm not sure if I have that correctly drawn on my graph. It might be off a little bit because I'm just drawing a sketch here, but we know that our answer is going to have to be from the asymptote, which in this case is at 3/4, until you get to that x-intercept. I'm going to need a bracket on that. So we've got to find that x-intercept. To do that, we're going to rely on the graphing calculator. And so you can see I've got the rational function x plus 6 over 4x minus 3. Also graphing a horizontal line at 1. And so if I graph it, you can see our graph looks pretty much the same as what I had drawn. And the important point is where the red and the blue intersect. And so I'm going to use the trace feature. It looks like it's maybe at 3. And sure enough, that confirms that they're crossing at 3, 1. And so, back to my problem here, since this point right here is at 3, 1, our answer is going to have to be from 3/4 to 3, because that's where the rational function is above the horizontal line of 1. Let's do another example. This next example, you can see we've got a rational function on the left, we've got a y value of 3 on the right, and we have to graph this function first. So I can tell that my vertical asymptote is going to be at 2. So I'll put that vertical asymptote in at 2. You can see that this is not going to have a horizontal asymptote, it's going to have a slant asymptote. So to find that slant asymptote, we're going to need to divide the top by the bottom. I'm going to use synthetic division for that. And so when I do that, looks like I end up getting y equals 1x plus 1 for my slant asymptote. And so if I graph that, it's got a y-intercept of 1, it's got a slope of 1. So that slant asymptote is going to look like this. All right, X-Intercepts, let's see here. If we set the numerator equal to 0, I'm not sure we'd get anything. Let's try that. Since the top is not factorable, we'd have to use the quadratic formula for that. So let me come down here and do that for the quadratic formula. All right, so if we do negative b plus or minus b squared minus 4 times a times c all divided by 2a, looks like we're going to get an answer of 1/2 plus or minus. I think that's going to be the square root of 45 over 2. And so I think that would simplify into 1/2 plus or minus. Let's say I break that down into a 9 and a 5. So we'd have 3 square root of 5 over 2. So those are two irrational values. Let's get decimal approximations on those. So if I do 0.5 plus, I think it was 3 square root of 5 over 2. Gives me about 3.8. So in my graph, I'm going to plot an x-intercept at about 3.8, about right here. And then if I find the other x-intercept, just type in the same thing, but I need to have a minus sign right here. And that would give me about negative 2.85. So that's going to be about right there. All right, y-intercept, if you put zeros in for all the x's, you're going to get a y-intercept of, what, 5.5? So if I go up to 5.5 and plot that, all right, based upon those points, the graph should be really close to the slant asymptote, and then it's got to go through that point and this point and approach the vertical asymptote. So this is what it looks like over here. And then over here, we're really close to the slant asymptote. We've got to go through that x-intercept and then move closer to this vertical asymptote. So that's what our graph looks like. If we put a horizontal line in at 3, we now have to identify when is the blue, in this case, below the yellow. So it looks like we have the blue below the yellow right here, which I'm going to describe that as negative infinity until we get to that coordinate point. We're going to have to find that coordinate point. So let's do that. Okay, you can see I've got the rational function entered on my calculator and a horizontal line at 3. So if we graph this, I got to figure out the intersection point right here between that blue and that red. So if I use the trace feature, and if I try to locate that, it looks like it's at -1. Sure enough, there it is. So back on my graph, since I determined that this point right here is at -1, 3, so I've got negative infinity to -1. Now we also have the blue below the yellow right here from the asymptote until you get to that coordinate point. So we're going to union this with the asymptote, which we know is at 2. And you always put a parenthesis on an asymptote. And I got to find that important point. So if I go to the graph, it looks like it's at 1, 2, 3, 4, 5. So let's trace. Let's go to 5. Sure enough, that's where that intersection point is. So from 2 to 5, you need to have a bracket on that 5. So you guys are going to have to use your graphing calculator to help you with some of these, but I do expect you to draw a picture, just like we did on these problems, to solve the rational inequalities.